So why use microwave apparatus in the classroom? Well, it's a really cool way of doing some optics experiments using electromagnetic radiation that doesn't fall inside the visible spectrum. It's a really nice way of grouping these types of waves together, showing that they've got the same properties, they adhere to the same set of laws, they all belong to the same family, and therefore Maxwell was right, and we can prove it. So let's take a look at the apparatus. So first off, we've got the microwave transmitter, which is this horny one. You can see on the top that we have got a dial for modulation frequency, and it also tells you that the microwaves it transmits are 3 centimeters in wavelength. At the back, this is where we power it. It takes 9 volts. It's got no CRO output, so you can't connect this to an oscilloscope and see what it's giving out. So to detect what it is transmitting, you need a receiver, of which we have got 2 types. First up, we've got the microwave plate receiver. So this is the area over which microwaves are received, and on the top of the unit you can see that you've got a knob for microwave sensitivity, and we've also got this, which is a little speaker. So what that means is that when this unit detects microwaves, it will sound a constant tone out of here, and the volume of that tone is proportional to the intensity of the microwaves at a fixed setting of sensitivity. So that's a really important feature of this apparatus, because it now means that it's super accessible. So if you've got any registered blind students or visually impaired students, it means that they can use this apparatus and get quantitative results simply by using their ears. So the last feature to mention about the plate receiver is the 2 terminals on the back that allow you to connect to a CRO and monitor the output. Now the output from this unit isn't super clean, but you've got to remember that it's a plate receiver, it sums the intensities across the plate, so there will be some stray scattered microwaves in there. But in terms of a relative indicative intensity, it's absolutely fine. So if you've got both the transmitter and the receiver, you are in a really good place experimentally. You can do so many experiments with just these 2 units. But if you want to do more quantitative investigations, you are going to want the microwave probe receiver. So this is a point detector which is located in the sail up here. And if you look at the front of the unit, again, you can see that we've got that speaker output, making it an accessible unit. We've got 2 settings though, so we've got one for volume and one for sensitivity. So again, this is a distinguishing feature. So with this unit, you can't decrease the volume, you can only decrease the sensitivity. So basically at 0 volume, 0 sensitivity. With this thing, however, it can still be detecting microwaves, but you can turn the volume right down. So if you want a quiet microwave lab, this is the way to go. Any experiment that you do with this guy is going to be noisy. Lastly, on the side of the unit, you can see that these are the terminals to connect to the CRO. So to finish, I'm going to show you typical signals on the oscilloscope from the 2 receiver units. So first, let's look at the plate receiver. So I need to give both units power. So it's 9 volts in the back of the transmitter, 9 volts in the back of the receiver. And then I've got a test lead here connected to the oscilloscope. So it doesn't matter which peg goes in which socket, they can go either way around. And then I need to increase the sensitivity on this unit so that it can register some microwaves. So all I've done here is I've used the auto set function so that it can automatically detect what the optimum volts per division is and time per division. It's a lazy way of doing it, but it's also the quickest. And then I've pressed this run stop button. So what that does is it will take a snapshot of the waveform at that particular point so that I can then turn this unit down and I can talk to you again. If I made the oscilloscope live again, please be aware that you would register nothing on it. So when you turn the sensitivity down, you turn the volume down as well, meaning that you get no noise, but you also get no signal. So just to show you up close what the signal looks like from the plate receiver, you can see that it's a cyclical oscillating signal, which you would expect from this type of apparatus, but there is some interference on there. So let's look at the probe receiver now. Okay, so same thing again, we want power in both units. This thing also takes 9 volts. You can see that the sockets are color coded, so we want black in black and red in red. We want to make sure that the orientation is with the sail facing towards the transmitter. It needs to be relatively close because it only works over a short distance. And then we need to increase the volume and the sensitivity so that we can register some microwaves. So I'll do that. So there we've got our signal from the probe receiver. I will just take a snapshot and then I can bring the scope over to you to see. So you can see that it's much, much cleaner than the one from the plate receiver, very little interference. So that is why if you want to do quantitative measurements, you're gonna need the probe receiver unit. So in my next videos, I'm gonna run through some experiments that you can do with this apparatus, and I promise you, you won't be disappointed. Thanks for watching.